Speed of sound in different media. Okay, sound propagates through medium at finite speed. The sound of a thunder is heard a little later than the flash of light is seen. This you know, since speed of light is more than the speed of sound. So we can make out that sound travels with a speed which is much less than the speed of light. The speed of sound depends on the properties of the medium. Okay. Speed of sound depends on the properties of the medium.
Sir, your screen is not visible.
Yes, sir.
The speed of sound in a medium depends also on temperature and pressure. Okay. Speed of sound will also depends on temperature and pressure. So what happens actually? So there is one expression like there is a relation between temperature and density, and there is a relation between density and speed of the medium. Okay, it has been given by Newton. Okay, so if temperature increases, density, the volume increases, so density decreases, then speed of sound will vary accordingly. In the same way, actually with pressure also. So these are all the change of speed with the temperature and pressure. We will learn as a higher topic. Okay, not now. Let me finish first this regular syllabus. I will give you a worksheet on this. Speed of sound varies, how it varies with temperature, pressure, and so any other factors. There is something called humidity. So with humidity, how it will be. So all those things we will be learning as a separate worksheet. Okay. And the speed of sound decreases when we go from solid to gaseous state. So in the solid, the speed of sound is the highest, and in liquids, it is of intermediary. And okay, in gases, it is the least. Speed of sound in air is 330 meter per second at 0 degrees Celsius, and in at some 22 degrees Celsius, its speed is 344. So in general, like in the problems when we are solving, we take 340 meter per second. Okay, we take 340 meter per second. So that you have to remember actually. Okay, it's a standard value. You have to remember speed of sound in air. So here they have given the table like speed of sound in different substances. In aluminium is about 6,420 meter per second. In nickel 6,040, steel 5960, iron 5950, brass 4700, glass 3980. So as you see, solids and liquids. So in the liquids, the values are little less, not little, less than those speed of sound in solids. And then gases, if you see, it is even less. But you see here, methanol is a liquid. Ethanol, compared to methanol, speed of sound in hydrogen is more, 1284 meter per second. So some of the liquids, sound travels even lesser than the speed of sound in gas, hydrogen gas. Okay. So on an average, we take 340 actually, 340 meter per second. Okay. Sound speed of sound in air. Then you can answer this question. In which of the three media, air, water, or iron, does sound travel the fastest at a particular temperature? In which of the media? Is it water or iron or air?
Sir, iron.
Yes. In iron, it is the highest. Okay. There is something called sonic boom. Sonic. Okay. When the speed of any object exceeds the speed of sound, it is said to be traveling at a supersonic speed. Okay. Speed of any object exceeds the speed of sound, it is said to be traveling at the supersonic speed. Okay. Bullets, jet aircrafts, etc. often travel at supersonic speeds. So their speeds are much higher than the speed of sound. So that those are called supersonic speeds. When a sound producing source moves with a speed higher than that of sound, it produces shock waves in air. These shock waves carry a large amount of energy. These shock waves carry a large amount of energy. And the air pressure variation associated with this type of shock waves produces a very sharp and loud sound called the sonic boom. Okay. So the objects which are moving with this more than the speed of sound, they are called shock waves or supersonic, that is supersonic speed, and that kind of waves are called shock waves, and that shock waves are associated with loud sound and very sharp sound, and those are called as sonic boom. So the shock waves produced by a supersonic aircraft have enough energy to shatter glass and even damage buildings. So with the sound energy also, we can damage the things. When the sound energy is moving with a supersonic speed, then it can also damage the glass, it can also damage the buildings. Okay, that is the effect of that energy. The next concept, very important concept. Based on this, you will get some one question you will get, and one numerical you may get. Compulsory you will get either numerical or theory question, compulsory, on reflection of sound. So just like a light, when it falls on the mirror, it gets reflected. In the same way, sound is also reflected, bounces back when it encounters a obstacle, when it encounters an obstacle. Okay. So that is called reflection, which is very simple. But here, one thing you have to make sure, like speed of sound, the relation you will get it as speed of sound v is equal to 2d by t, 2 into distance by time. Very important. 2 into distance by time. It is not distance by time because the sound is traveling, moving up journey, and after getting reflected, It is doing down journey, up and down journey it is doing. Okay, so that's why 2 into distances. Speed is equal to 2 into distances. Okay, so very important. V is equal to 2d by t. That is important here in the case of reflection of sound. Okay. Based on that, you may get numerical, and based on that only the concept called sonar works, echoes works. Okay. So this activity, it is just giving like 2 pipes you are taking, and there is an obstacle called wall. Wall is obstacle. If a person is there, person is obstacle, and mountain is obstacle. A tall building is an obstacle. All are obstacles only. Okay. So whenever it gets an obstacle, it reflects back. You can listen it through this pipe. 2 pipes are there. Incident sound is incidenting, and it is falling on the wall and getting reflected. Okay, and we can hear it through our ears. Through this pipe, it gets reflected. Okay, and that reflection only we call it as like that reflection of waves leads to the concept of an echo. Okay, echo is like if you shout or a clap near a suitable reflecting object such as a tall building or a mountain, we will hear the same sound again. Okay, a little later. So that sound we call it as an echo. Okay, so that is because of reflection of sound. Okay, so there is something called our sensation, our ear sensitivity or persistence of ear. Like when two sounds are the time gap between the two sounds, if it is 0.1 second, then we can listen those two sounds as a different sounds. Okay, and if it is less than 0.1 second, then we will hear it as even if they are same sound, same two different sounds also, but we hear it as also here as a one sound only. So once again I repeat, persistence of ear. Our ear is having some sensitivity, like we can only distinguish two sounds as a two different sounds. Okay, whenever the sound waves, the time gap between the sounds are less than greater than or equal to 0.1 second. Okay, if the time gap between the two sounds is less than 0.1 second, then we hear those two sounds as one sound only. Okay, so that is what persistence of ear. Prachita's question: in caves, due to the wall of the caves, we can hear the sound multiple times. Yes, so in the caves, the rocks are acting as an obstacle, so that's why we hear. The sound is traveling and it is facing an obstacle, rock, wall, mountain, tall building, whatever obstacle, then it gets reflected back after 0.1 second. It reaches our ear, then we listen the sound again. Okay, so there should be a time gap, 0.1 second. Okay,
Basically, sir,
yeah, Subhajit.
sir, I have one doubt.
Yeah, tell.
Sir, means I'm telling that, sir, in Prachita's question, she asks that in caves, due to the wall of the caves, we can hear the sound multiple times.
Yes.
So, sir, means the distance between the observer and the wall should be means equal to 17 centimeter like that.
Yes, 17 meter, not 17 centimeter.
Sorry, sir, 17 meter means it is necessary for the sound to be echoed.
Yes, it is necessary, and that is the proof that we are going to learn now. Why 17 meter is required in order to hear an echo? So speed of sound is 340 meter per second, and persistence of ear is 0.1 second, and speed is equal to 2 into distance by time. And if you simplify that distance, you will get it as 17 meter, minimum 17 meter. 2 into distance by time, you have to take speed formula. So if you simplify, you will get the distance to be maintained between the source of sound and the obstacle is 17 meter. Okay. Okay. So that is what here it is given, but if you find out in a, like if you take 344 meter per second, then you will get the answer as 17.2 meter. If you get the speed of sound as 344 meter per second, then the minimum distance to be maintained is 17.2 meter. Okay. This distance will change with the temperature of air. Okay. So if the distance change, so if the temperature is changed, no, speed of sound is also changed. Okay. Then accordingly, distance will also be changed. Okay. Arpit question. In case of empty room, I can hear echo, but when there is a bed, almirah, and etc., the sound is observed. Yes, these are all observers. In an empty room, there are no observers for sound. So that's why you can hear an echo. It goes to the wall, and again it reflected back. But if there is an observer, what happens? If there is an observer, so sound will not get reflected back. Okay. Arpit, is it okay?
Yes, sir.
So echoes may be heard more than once due to successive or multiple reflection. If there is a single reflection, once we hear. If there is a multiple reflection, many times we hear echoes. The rolling of thunder is due to the successive reflection of the sound from a number of reflecting surfaces, such as the clouds and the land. The thunder sound is also associated with echoes. There are many reflections are taking place. Okay. And next. Reverberation. Reverberation, if we talk about, a sound created in a big hall will persist by repeated reflection from the walls until it is reduced to a value where it is no longer audible. Okay, you keep on listening the sound until unless its amplitude becomes 0. Okay, it gets reflected, reflection takes place, keep on going on. Okay, until unless its value becomes 0, the multiple reflection will go on. Okay, so such kind of repeated reflection that results in this persistence of sound is called reverberation. Okay, the sound goes and falls on the wall and one reflection takes place, and again from the wall on the floor it falls and again one more reflection, and again from the floor on the wall, and like that something. So it goes on multiple reflections. That kind of multiple reflections we call it as reverberation. Okay, in an auditorium or big hall, excessive reverberations is highly undesirable.
এটা তো খুব ভালো স্যার
Punit,
মানে এখানে what
Hello, sir.
yeah, Punit, what is your doubt?
Sir, my doubt, Arpit.
Arpit, okay, yeah, tell.
Sir, what is the difference between reverberation and echo?
Echo is a single reflection. Multiple reflection is reverberation. That is the difference. To reduce reverberation, the roof and walls of the auditorium are generally covered with sound absorbent materials. Okay. To reduce the reverberation, we use some of the absorbers. Okay, like fiber board, rough plaster, or draperies. The seat materials are also selected on the basis of their sound absorbing properties. The seat materials are also selected on the basis of their sound absorbing properties. Okay. So fiber board, rough plaster, or draperies. Rough plaster is only called as draperies. Okay. They are used for to absorb the sound waves, so that you can avoid multiple reflections. That is only reverberation you can avoid. Yeah, till now, what we understood is, like after the break, like sound travels differently in different speeds in different media. Okay, that we understood. In solids, liquids, gases, it is different, and there is something called reflection of sound, just like light reflection, how it takes place on the mirror, and sound also gets reflected when it encounters a obstacle, and that reflection of sound only leads to an echo, and echo requires like minimum distance of 17.2 meter or 17 meter to listen an echo, and that multiple echoes or multiple reflections, we call it as reverberation. Okay, reverberation, multiple reflections or multiple echoes, we call it as reverberation. So that reverberation is actually undesired. In order to avoid that reverberation, we use some fiber boards, some rough plasters on the roofs or top of the buildings. Okay, in a movie theater, you can see, okay, the sound should not be reverberated, otherwise the audience cannot enjoy the movie. So in such a way, they will do the setting, like using the sound absorbers at a proper place, and at the same time the sound should be audible to each and every audience. So they will maintain that. Okay. Let us try to do this question. Based on this example, you may get some numericals. A person clapped his hands near a cliff and heard the echo after 5 seconds. What is the distance of the cliff from the person if the speed of the sound V is taken as 346 meter per second? So distance they are asking. So speed is equal to 2 into distance by time. That is the formula you have to use, and distance we find out. Speed is given, time is given, distance you find out. Speed is equal to 2 into distance by time. And 65 is the answer. D is equal to 2D by T. D is equal to V into T by 2. D is equal to V into T by 2. V is there, T is there. By 2 you do. 346 into 5 by 2 will give you the answer 865 meter. Please take care. Speed is equal to 2 into distance by time, not distance by time. Because there is a up journey of the sound wave and down journey of the sound wave. So that's why we will take the total distance traveled by the sound wave during a reflection is 2 into distance. Okay. The next question. This also you do similar example. Similar to the example, an echo is returned in 3 seconds. What is the distance of the reflecting surface from the source, given that speed of sound is 342 meter per second? The next, uses of multiple reflection of sound. Megaphones are loud hailers, horns, musical instruments such as trumpets and shehnais are all designed to send sound in a particular direction without spreading it in all directions. Okay, so all those, so they are designed in such a way that the sound has to travel in one direction. In these instruments, a tube followed by a conical opening reflects sound successively to guide most of the sound waves from the source in the forward direction towards the audience. See this kind of conical shape, okay, that results in sound successively to guide most of the sound waves from the source in the forward direction. Okay. That is the one of the, like, it is getting reflected at the conical surface. Multiple reflections are taking place, but still we are guiding with that shape into the forward direction. All the sound waves are moved towards frontwards. Next, stethoscope. Stethoscope is a medical instrument used for listening to sounds produced within the body and chiefly in the heart or lungs. In stethoscope, the sound of the patient's heartbeat reaches the doctor's ear by multiple reflections. In this way, see, multiple reflections are taking place in the stethoscope. So that is why the sound is traveling. Otherwise, no, it will distribute. It will be, if there is no multiple reflection and guiding towards one direction, then the sound waves may move here and there. Then the doctor may not hear through in the stethoscope. This is what happening, multiple reflections. And then generally the ceilings of the concert halls, conference halls and cinema halls are curved so that sound after reflection reaches all corners of the hall as shown in figure. Okay, this is what happens. See? Curved ceiling of a conference hall. Since it is curved, so it goes like this, it reaches here. And whatever that it falls here in this curved surface, it reaches this line of audience. And it reaches this line of audience. So that it reaches every line. Okay. After reflecting from the soundboard, it spreads evenly across the width of hall. So this is what multiple reflections are taking place on the curved surface. So curved ceiling should be there for a conference hall. Okay. Soundboard used in a big hall. So what happens? You see, source of sound is here. There are many sound waves go and hit on the curved surface. What happens? Then finally it gets reflected back and into the reflected back and guided into the one direction only. This is the sound board. Okay. The singers you might have seen they uses this kind of sound boards all. Okay, they uses. Okay. And they are guided. The sound waves are guided with this curved shape in one direction. So this question we have understood. Why are the ceilings of concert halls are curved? Because for the multiple reflection, here is one reflection, here is one reflection, here is one, and also it has to be reflected back to the particular line of audience. That is the reason.